Good afternoon. My name is Nicholas Spalding. I'm the SI leader for Math 1121, and today we will be reviewing for this week's exam, covering definite integrals, work in the spring, and 5-2, 5-4, 6-2, and 10-2. We'll start with 5-2. Do you have any problems in particular that y'all want to work?
Just kind of go through.
5-2. The homework or lecture notes?
Let's see. What's 5-2?
Start with 5-2, right?
5-2. I'm kind of good on that. What about for you, Anton?
You just get through a quick one, yeah. Just
Okay. From the homework?
Yeah, that's fine.
Exercise 1 through 7, all right. So you want to start with number 7 first?
Just one would be fine for me, just to see it.
Okay. Okay, number 1.
Or 7, just have to just
Okay, 7.
Yeah, just need to do one.
Number 7. Excuse me. Number 7 starts out. Integrate x to the negative 4 dx. Get my those are my two methods for antiderivatives.
Uh-huh.
This one, I usually use this one for is it polynomials? What it got exponents, and this one is pretty. This is the simple one you could use for something like this. Just one term. For this one, they give you n minus 1. For this one, they give you n. So if you want to integrate x to the negative 4, we're taking the derivative of x to the negative 4. So we're going to let u be x, let u equal x. N equals negative 4, n plus 1 equals negative 3. U n plus 1 over n plus 1 equals x to negative 3 over negative 3, or negative 1/3 x to negative 3 plus c. Don't forget that plus c. If that plus c is only for if you don't have a and b. If you have A and B up there,
You just plug those in.
yeah.
Okay.
But if not, add plus C to the end for a constant.
And then you write it K, U.
And this is it. That's for
The 1/3 is.
that's the antiderivative. Yeah.
And that's just written KU.
That's the form already there.
Yeah, that's that
Yeah,
form.
that's the form. Yeah.
So isn't there one more step to solving for KU? How do you
You want me to do it the other? I'll do it the other
Yeah.
method. I'll use the other method. So for this method, u is going to be x. N minus 1 equals negative 4. So that means n would be negative 3. And then they give you this form. This is the antiderivative form. This is the form they give you. You're trying to get it for this form, so you write k. You're looking for k. N equals -3. We're looking at this one. K, -3 is n. U is x. N minus 1 is -4. Equals the function, the original function, x to the -4.
Okay, it equals -1/3.
X to the -4 cancels out. You're left with -3, k equals 1. K equals -1/3. And then write it back in this form right here. K equals -1/3. U equals x. N equals -3 plus c. You got that one?
Mm-hmm.
You want to move to maybe 19?
The 3,
Okay.
it's KUN. The N is the
Which one? Where
I
you
don't
at?
understand why the N in the N plus 1 is different in those two examples.
Right here?
yeah.
Why the N is different? I'm not sure. I think that confused me too. But what works is when you do that, when you use this method, they give you N minus 1.
Okay.
When you do this method, they give you N, and it'll work. It'll always work.
Okay.
And then set it equal to the original function right here,
Mm-hmm.
and then solve for k,
Yeah, I get
and
that.
then put that back in. Yeah, but yeah, that messed me up too a little bit. Okay, you erase this one? You want me to move on to maybe number 19 or another one from this homework?
Yeah, that's fine. Do one
Okay.
more.
Uh, 19? Is that all right? 19, section 5.2. Integrate 1 plus 2s squared ds. I'm going to start off by foiling or simplifying. 1 plus 2s squared, 1 plus 2s squared, 1 plus 2s squared plus 2s squared plus 4s to the 4th, 1 plus 4s squared plus 4s to the 4th ds. So this is your rewritten question. And then we can just take the derivative of each term now.
All right.
So derivative of 1 is x. I'll write this in different. Derivative of 1 is x. Can you see that without doing any work with that? With this one? This constant?
Yeah.
Okay.
Well, why is it X? I thought it would be 0.
That's the derivative. You want to go the other way, antiderivative.
Okay.
So put the x on it.
Okay.
When when you come the other way, it's 0. Derivative of 4s squared. Take out the constant. Un plus 1 over n plus 1. S cubed over 3. You see that?
Yeah. This is the day I missed. So
Okay. I can do the work. You want me to do the work on the side?
yeah, I see it. It just
Okay.
like you
Just let me know.
Explain to me what you just take the S out.
Right here.
Yeah,
you take the constant out first. So you separate the constant. And just deal with the s squared.
Okay.
And take the antiderivative of s squared.
So that's the third over 3.
Use this equation. S cubed over 3.
Yeah.
And then put the 4 back in there.
Yeah. It's just derivatives working them backwards. Yeah. So you just gotta think how it looked before. Yeah.
You see it?
Yep.
All right. Plus s cubed over 3 plus the next one. Go ahead. Help me with this next one too.
4 s to the 5th over 5.
All right. ds. This is the antiderivative. ds. ds come. Yeah, ds come. And this is your answer plus c.
So you drop the ds.
Well, you can simplify though. Yeah. So it could be 4/3 s cubed plus 4 over 5 s to the 5 plus c plus x. Is that x? It's s, not x.
So when you're integrating, you're always looking for the antiderivative?
Uh-huh. Yep. And when you got a and b up here, as soon as you find the antiderivative, you just plug it in. FB minus FA.
Okay.
And that's your answer. And always high minus low. Okay, you erase this one?
Mm-hmm.
All right. Next section?
Yeah.
All right. 5-3. No, 5-4. Definite integrals. You want to pick one from the homework? How you doing? How about?
$17 there?
Okay. Number 17, section 5-4. Reads, integrate 4 to 0 x dx over x squared plus 9. You see where we're at? I'm gonna start off with rewriting it first to get rid of the radical. So, integrate 4 x squared plus 9 to the negative 1/2. That's a 9. X dx. or x on this side. I think we're used to seeing it on the other side. So x. So this one, this u n plus 1 over n plus 1, that doesn't apply for this one. For these exponent ones, you have to find k. So we rewrote it. Then we're gonna list what we got. Let u equal x squared plus 9. Du equals 2x. They give you n minus 1 equals negative 1/2. That means n would equal negative 1/2 plus negative 1/2 plus 1, which is 1/2. That's it. So we're looking for k. Write it like this. K, n equals 1/2. U equals x squared plus 9. N minus 1 equals negative 1/2. And all that, excuse me, yeah? No. Du. So 2x. Chain rule. You see the dx.
And you set that equal to the the original.
Mm-hmm. Set that equal to the original x squared plus 9, so negative 1/2. This x squared plus 9 cancels out. This cancels, x cancels, 2 cancels, and you're left with k equals 1. So write it back.
You said I wasn't watching. How'd you cancel everything out again? Sorry.
I
see how x squared.
Okay, you see how this cancels?
Yeah.
X squared plus 9 to negative 1/2.
Yeah.
And then you see how this x cancels right here?
Yeah, just the x.
Yeah, just the x.
Yeah.
But the 2 cancels out with the 1/2 right here.
Oh, so that's 1. Okay. I got you.
And then that's everything. K equals 1. And then rewrite it in this form, back to this form.
Yeah.
So k equals 1, u equals x squared plus 9 to the n, which is 1/2.
Plug in.
I'm not sure if dx goes in there. I don't think dx goes in there. Yeah, dx don't go in there. You got this?
Yeah.
I'm gonna erase something on this side. Can I erase up here? From here, this is your antiderivative. You want to plug 4 and 0 into the antiderivative, basically like this. 4 minus f of 0 equals. And I just put those into my calculator instead of I show them like I show them like this, that I plugged it in and just put it in the calculator. X squared plus 9 to the 1/2. graph that.
X squared. Oh, it is x squared.
Yeah, x squared right here. Graph this. Graph the antiderivative. And then you plug your values in. Value 4. So this equals 5. F of 4 equals 5 minus
0.
F of 0, which is 3, equals 2. Yep. You good with this one?
Mm-hmm.
All right. I'm delete, erase this one. You want another one from this section?
Yeah, try 31.
31. 31 reads, section 5.4 says integrate 3 square root 5 2z root 4 z4 plus 8z squared plus 16 dz. Oops, excuse me.
It's really the same. You just put all that to the 1/4.
Yeah, put all that to the 1/4, rewrite, get rid of the radical. So if you rewrite it, it'll say 2z z to the 4th plus 8z squared plus 16 to the 1/4 dz. And then same thing, integrate, take the antiderivative using this. So we're looking for k, u, no, this is we can do each term, right? You can simplify this more. This could be rewritten z squared plus 4 squared to the negative 1/2 to the 1/4. Excuse me. You see that?
To the negative 1/4? Or just
No, positive 1/4.
Okay. Okay.
So that's going to be 1/2 at the end, right?
Yeah.
After you multiply these.
So it's 2z z squared plus 4 to the 1/2.
Yeah. And now take the antiderivative.
So u z squared plus 4 prime
Looking for
2z.
K. They give you n minus 1. They give you n minus 1 equals 1/2. N equals
3/2.
3/2. du, I think u equals
2z.
z squared plus 4. du equals 2z. That's it. I'm gonna erase some stuff at the top.
That's fine.
So, take the antiderivative. We already list our data. Write it like this: K N U is z squared plus 4. N minus 1, 1/2. du 2z, the chain rule, equals the original function, which is 2z, z squared plus 4 to the 1/2. You there? But good. Cancels. You're left with 3/2 k = 1.
K equals 2/3.
Yeah, k equals 2/3. And then write it again like this: ku to the n, 2/3 u. I'm gonna write this somewhere else. You see what I'm at? K u z squared plus 4
To
to the
3/2.
n, 3/2. What are we doing? Is that -3? 3. And square root 5. After this, you got your antiderivative already. Just plug it in, plug the upper bound and lower bound.
That's always upper minus lower.
Uh-huh.
Okay.
And for that, when you do the horizontal, you're looking for doing the area under the curve with the horizontal test. It's always high minus low too.
Oh, yeah.
So it'll be right minus left. And we can plug this into the calculator.
Yeah, I think you said that's fine.
This fine right here? Okay.
Mhm.
Yeah. That's all you need.
Yeah, I'm good on that.
Any more from this section? You want to do any more from this section? 5-4? No. 6-2 next. I'm gonna pass around a tender sheet right before just 800 name and 800 number. Next section is 6.2. You wanna pick one from here?
Yeah, we can pick right one. Whatever.
It's number 1. Number 1 says, this is section 6.2. Number 1. Y equals 4 minus 2x.
Oh, this is number 2?
Is that number 2? Okay, I'm sorry. 4 equals, what is it? Y equals 4x. And y equals 0 and x equals 1. So first thing I want to do is see what the graph looks like. First thing I want to do is see what the graph looks like. So I'm going to graph it. 4x. And I see it's a straight line slope, increasing slope. I'm going to draw it. Something like that. I'm going to find y equals 0, which is right the y-axis. I need to make that bigger. Okay, let's try this. So 1. This is x equals 1. This is y equals 0. Y equals 0. This is y equals 0. X equals 1. And you got the curve going through there. Let's find out where 1 is. X equals 1. X equals 1. So X is about right here. So, you see the area that we're looking for? Yeah. And we can put a vertical line in to sum the areas all the way across X. And we're gonna write the equation. So the area equals the summation. The integral. This line is y equals 4x. And this line is y equals 0. So your equation is going to be high minus low. 4x minus 0. Or, yeah, dx. Good. All right. I'm going to go ahead and take the 0 out. You don't need it. And then I'm going to take the antiderivative of 4x. You want to walk me through that antiderivative?
Yeah, it would be 4 x squared over 2.
Yeah. And then you got to simplify. 2x squared. I forgot to put the... You see the upper bound and lower bound? You see how you got that? 1, 0.
Yep.
Everybody see how you got that? The upper and lower bound? Let me back up.
Yeah, just 1 and 0.
Okay.
Yeah, I got it.
I was making sure.
Appreciate it.
And then antiderivative, you got the antiderivative, got the upper and lower bound. And then f of 1 minus f of 0. Good.
Yeah.
Okay, that's just a antiderivative formula, right? The KUN.
Right here?
Yeah.
And but we didn't use that one. We used we actually used this one right here. You can use this one all the time, but this is only for a single term without the exponent, just like that 4x.
Right.
Well, if you see something with the exponent, you can't use it, like x squared, something like that.
Oh, you can't use the.
You can't use this.
Oh, I got you. Yeah, makes sense.
And this one,
I remember that.
when you use this one, they give you n. When you use this one, they give you n minus 1. So you just got, when you're doing that, u equals x,
Yeah.
n minus 1, stuff like that. They give
Is that
you-
f of 1 minus f of 0 just for this integral stuff that we're doing, right?
You got those numbers from the X and the Y up top, right? That's where those numbers come from?
Yeah, right here.
Yeah.
Well, really you put it on here and then see where your area, your boundaries for your area is, because you can see right here, you got the vertical line, so your boundary is y equals 0 at the bottom, and that slope line at the top. You see it?
So it could be different than like, it just happened to be on this one that y equals 0 and x equals 1 is the same as the boundary numbers.
Yeah, I think it can be different.
It can be different.
I'm not sure if y'all will have one.
Okay. I'll look it back over and see if
Okay.
any of them are different.
I'll do some more. I'm gonna do some more though.
Oh, that's right. Yeah.
Oh,
Find out.
you good with this one?
Mm-hmm.
Okay. Oh, you want to pick one? Just go down. You want to pick a number?
Y'all still want to do a 6-2 or what y'all want to do?
Yeah, let's stay in this section. 6-2.
I guess we can just do the next one, 11. Did you guys get that? I mean,
Just straight.
Okay.
since it has a square root, since it's square root, just so we don't. I mean,
That's fine. Y equals square root of x. X equals 0. Y equals 1. Y equals 3. So you got 3 right here.
oh, should I just now notice that? I don't even think I thought about it whenever we did it, or whenever I did it at home.
So I'm gonna graph it first. Square root of x. Graph it. It looks like this. Looks like this. And we want to find out where x equals 0 at. Where is x equals 0 is the y-axis. So one boundary, y equals 1 is right here somewhere. I'm gonna find out exactly where it is from the value y. Oh, y equals 1. Y equals 1 at x equals 1. And y equals 3. That's up here. 2, 3. Y equals 3 at x equals 9. 3, 4, 5, 6, 7, 8, 9.
So what are you graphing on your? What are you doing? Oh, you just graphed y equals the square root of x on.
Yeah. The square root of x.
And what are you looking for now?
The red is the function, and I'm trying to find the area. I'm plugging these these lines in right here to try to find what the area under the curve they want.
Okay.
Was like your boundaries.
Okay, I got you.
So the red is the function, and they give me some boundaries right here.
So that y equals 1 is going to go all the way over to that 9 too. And you
Yeah.
put area above that.
Can you just plug it in?
9 y equals 3.
Once.
And you're just looking for
This area right here.
Yeah.
Yeah.
Y equals 1, y equals 3, right? Like that, just at the bottom, under it.
And we can use the vertical line through this. The vertical line.
Why do you do that?
The vertical line. The vertical line represents a line. Say on one. What is this? 1, 2, 3. So if you put a vertical line on 3, that's the area under this curve at 3. And then you're gonna sum all the way across X under that curve. You're gonna sum all those vertical lines, and that's what the integration do.
All right, go through that. I'm gonna see if I figure out why you do it.
Okay. So we got our boundary. You see how to get the boundary?
Yeah, I just plugged in, I just typed in y equals 1 and y equals 3 under the function. And then,
Okay.
That shows your
You put it
boundaries.
all in the calculator.
yeah, but obviously you can't do an x equals 0, but I know, obviously you know where the x equals 0
Yeah.
line is at.
Okay.
But like, I didn't know what you guys were referring to when,
okay.
just now
Yeah.
with the vertical
We were
line.
trying to put it in the get it like you drew it in the calculator.
Oh, okay, I got you. So, all right, just, yeah.
So we got our boundary. This is x equals 1. Excuse me. This is y equals 1. This is
Right.
y equals 3. This is y equals square root of x. Right, that red. And this is x equals 0. So
Okay.
here's a boundary. Here's a boundary. And here's a boundary. And that so we got the area. We want to subtract. We're doing the vertical line, so we want to subtract the top function by the bottom function. The bottom function is y equals 1. So square root of x minus y equals 1 with those boundaries on the x-axis. So our boundary is 1. No, I believe 9 and 1. 3 and 1. Oh, we gotta do we gotta do a horizontal. Sorry about that. I didn't understand that when he said the top stays the top. You can always do the vertical line test. That's what he said, right?
I think
Yeah, I think with the vertical line test, he's just making sure the top stays the top and the bottom stays the bottom. If they were to switch at all during your function, I think that's when you would have a problem.
But see, that one that doesn't switch.
Going that way?
Don't-
Yeah, but you don't have a limit going that way. You get what I'm saying?
Okay, just up and down, right?
Yeah, because if you went that way, it'd just extend on forever.
Okay.
But you do have a limit. At y1 and y3, you have a
Yeah.
limit going up and down the whole time.
Okay. So we still want that same area, just a different way.
Yeah.
We're looking at it this way. So we got to rewrite this to reflect. Basically, you want to rotate the axis, and to do that, you got to solve for x. So y equals square root of x. Solve for x. Square both sides. Y squared equals x. Right? So that's your function.
Why do you do that?
Huh? Y squared equals x. Huh? What's that?
Go ahead, keep going. I'll
Okay.
finish.
So,
Excuse me.
Oh, x equals y squared is just the
Solve for x.
the opposite of y equals for x.
Yeah.
Another way of writing it. I don't know. I guess that,
It's
just another way to confuse somebody who's trying to figure it out.
basically you're rotating the axis when you do that. You know what I'm saying?
Oh, because you're setting y equal to. Well, it's already y equal. Why would you want
You see how
y squared equals
right
x?
here y is dependent of x. This way x is dependent of y. You know what I'm saying?
So does it just make it easier to read from as far
You
as.
see how this one you put the x in the x is the input.
Right.
On this one the y is the input.
Oh, okay, I got you. So.
It's like he was saying, if it was X, you'd have an infinite number of answers.
Okay, I got you. Now since it's y, you can kind of make something of it.
Kept going. Yeah.
Gotcha.
So
It would have been, instead of where you put 9, if you'd done x, it would have been infinity over 0, and you would have never found an answer.
Uh-huh.
Yep.
So area equals the integration. You got your upper bound, lower bound. It's 1 minus y squared, right? Y equals 1. It got y squared minus 0.
Yeah, it's just, it'd be minus 0, wouldn't it? Because there's no other,
Y squared minus 0.
there's only one function here. Right.
Yeah.
What did he put in?
He put y squared minus 0.
Yeah. Because there's only one function. If there's two functions, then you subtract. Because you take the top one and you subtract it by the bottom function, like if they cross or if you have two functions. But since we only have one function here, right, it would just be the top minus 0 because there's no bottom function.
Okay.
We're just using a limit.
As the I thought you used that
'Cause if
equation
that-
for that boundary.
Well, no, I don't think so. Because, see, if that boundary wasn't there, it would just continue to go on and on. The boundary's just kind of looking at it at a...
Yeah.
The boundary's just taking the area of that function, just a small portion of it.
3 to 1. Okay. Gotcha. Y'all, everybody else see that though? I'm gonna go ahead and erase that. I think it'd be dy. Antiderivative y cubed over 3. And then f of 3 minus f of 1 equals 0. I think we should do another horizontal one. Do another horizontal.
Mm-hmm.
He said we didn't have to solve it all the way, correct?
Yeah,
So
y'all said this was good, right?
Yeah.
I don't know. I mean...
I know there was one thing he said that we could leave simplified. Or not simplified, just leave it how it is, but I don't...
Yeah, I don't remember exactly
That
which
was
problem set it was.
Integration by substitution when you were solving, you had let u equal that,
Yeah.
and then
Yeah, that was 10-2.
That's right, 'cause-
we don't have to simplify.
Yeah, I think these were...
Because it was towards the end of
So
the class the other day.
this one, I would say we have to figure it out because it's not really hard from there on out.
yeah, you just put
plug
it in the calculator. Yeah. That's what I did. I did it like this. I showed them. I plugged it in like that, and
Yeah,
I just solved
showed
that in
him
my
that.
calculator. I can erase this one.
So when you do f of 3, that's just the original
here?
function, correct?
This is the capital F is the antiderivative. So this is the antiderivative. You plug in 3 into here.
Oh, okay, I got you. All right.
You thought as y.
Yeah, I got you.
So 3 cubed over 3 minus 1 cubed over 3. Good.
Yeah, I was just saying, I guess x doesn't come into play whenever you solve it.
Where
Yeah,
no,
The-
you
The
right
original
here,
X?
we changed it. To
Oh,
make the
because
Y
we
input.
changed it, that eliminated the use of
Our Y, so our Y is now our X. We
okay.
rotated the axis, so our X was right here. You could look at it like, I don't know if that helps to look at it like that. But when we did this, we rotated the axis, so Y is right here now, and X is like this.
Yeah, it helps because, I mean, visual stuff, like,
Yeah.
I remember that more
So-
than just,
No,
like, rules,
Did
yeah.
you say this one had a wrong answer on the solution manual? Because this has got a different answer.
Which one?
That one we just did 11.
It's got a different answer. Y cubed over 3. Isn't that what I got?
And the solution manual says 26 over 3 is the answer, so.
Oh, the solution manual.
Yeah.
Oh, besides from his?
Let me see.
I don't have that one.
Software.
Can I borrow your solution manual?
Yeah, dude. I was gonna look at his online and see. Well, you got it brought up. That's it on the screen, right? His solutions.
That's his.
Okay.
Yeah. This is 6-2, right? Number 11. They did Y squared did.
Supposed to be 27?
Yeah, see, they did that. They did that. They put that 1 in the
Oh,
equation.
yeah, his is.
What's your name?
Hmm?
They the book. Can you see this right here?
Yeah, it uses 1.
Yeah, it uses that 1 as the.
So then is he wrong?
That's what I was thinking that you do use the. That's how I've been doing them too. To use that lower bound as the other function.
Yeah, right there.
Yeah, they put that y.
They do.
What is it? Y equals 1.
Y squared 1/3.
See, this is how they do.
Wait.
Oh, my
Yeah, let
bad.
me see that.
My bad.
I got it.
Sorry about that.
Yeah, right there. That's fine. Right there. So they got x equals y squared. X equals dy, which equals y squared. It's 1/3 over y. That's what we got though.
You
That's
see
what
where
we-
you
that's
see
what
where this
we got.
1 is?
That's what I
Yeah,
got.
they didn't write it in there though, but they got that -1 right here. That we did. Let me write this again.
I did it that way.
You did it this way?
Yeah, because you use your y values.
Yeah, no.
So which would be 3 and 1.
So it'd be area equals 3/1
Yeah.
y squared minus 1.
No, that wasn't in the book. I didn't see it in the book. I must be missing it.
When they take the derivative right here.
Can I come? I'll come up and
Yeah,
look
yeah.
at it because I didn't see. Maybe I'm overlooked that, but I didn't see that in the book. I was looking.
When they see that's the antiderivative of y squared, right?
Yeah.
And then that
Yeah,
minus
but
1.
see what you're writing right now.
Yeah, they didn't put it. Yeah, they didn't put it up here, but they put it down here.
You put like books.
No, they didn't.
Yeah,
That's when
okay.
they. That's when they plug it in. That's when they plug in their 3 and
Oh,
1.
both.
That's what yours-
Okay, both
This is-
bounds. Okay,
Yeah.
appreciate it.
But it's a little easier to have this with you.
You do, because I can like all my books.
Okay, my bad.
Couple notebooks and that.
This semester, they didn't have a lot of books.
So the area equals 3/1. So why didn't we get the same answer then?
That's what I got what the book got, the 27
Oh, you did?
over 3 minus.
Yeah, I think.
3 over
I think
1 over
he
3.
calculated or did something there.
So we was right. Like that, right?
Yeah, I got 26
Did you put a
over
zero
3.
at the-
Is that what the book got? 26 over 3.
Yeah. You can put it because there's no lower. There's no
see,
lower
see your
function.
function at the bottom, does that say 0? F3 minus
Yeah.
F.
Yeah. Appreciate it.
Here's a good way to explain. It's basically like in the other one where you had 2 functions, right? And you had your 2 functions that crossed each other.
Mhm.
In this case, you still have 2 functions. Your 2 functions are x equal y squared and x equals 0. That's your 2 functions. But since x equals 0, it doesn't cross your other function, so that's why it's minus 0.
You know what he did? He did the same thing I did. Yeah, he did the same thing I did. 3 to the third power, he put his 9 instead of being 27.
Oh, okay, yeah.
Yeah, instead of 27, yeah. That's what you did.
Good call.
But anyway, that's why it's 0. Oh, I see what boundary he's measuring there. That's the boundary it should be. We're marked the wrong boundary. That's why it looks like it goes to infinity.
Oh.
Yeah, do you see the boundary he's marked, and then the boundary you've marked there is on the other side of the.
Yeah, his boundary is solved for x. It's
Oh, it's the one above
inverse
that.
here.
It's this one. He did.
Look at his key to try to.
Yeah, and so that would maybe make more sense now when you look at it, how it's inside of
If you zoom in, you can see it.
an area, and there's no.
It's not under the curve though. That's why I guess.
But yeah, he made
Well,
that. He definitely made that.
it is when you flip it. Remember?
Oh, okay, cause
Yeah, when you flip it, it'll be under that curve. It'll be in between.
just
so
making
let's
it
graph
easier.
y equals.
It really doesn't matter. I mean, if you just think about it, it doesn't necessarily have to be under the curve when you as just in between two curves, if that
Okay.
makes sense.
Yeah.
But you're right. I mean, it does help because if you know what it's under, then you know
Yeah.
what minus the other.
Yeah.
Why can't we have it in this room? That's what I want.
Because if it were to flip the other way, it'd be 0 minus whatever, which would completely change the thing around.
This,
Yeah.
this big. I ain't
But
using
yeah, in
it.
this case, it just flips, so it's the top one is x equals y squared.
Okay.
You can barely put a notebook on it.
It's a bit tricky. I'm learning it today too as we go along. I'm starting to figure things out that are connecting.
Light bulbs.
Yeah, yeah.
It's easier when you can go slow, though. He just goes too fast.
I agree. He goes too fast.
I mean, I know a lot of it's you got to teach yourself, but it's
Yeah.
just as
Like, I
fast as
wasn't-
he goes, it makes it confusing because he takes shortcuts and doesn't explain them thoroughly.
Well, my part is not only does he go fast, you still have, like, I still have to translate in my head exactly what he's enunciating. You know what I mean?
Oh
I
yeah.
get confused sometimes, man, because I don't know exactly what it says. But
And his voice squeaks.
yeah, and he's going fast, and it's like, wait a minute, you can't copy everything down and watch him. I mean, you just get lost, and so I'm lost. That's why I'm lost now, because
Yeah. This really isn't that bad though. If you know how to do the antiderivative, or if you know how to do 5-4,
yeah,
then this stuff isn't that hard really. You just need to know what area you're looking at.
it's just an extension from that.
And then once you know that, you need to know what curve is above the other one, and then it's just the top curve minus the bottom curve.
Yeah,
I mean, it's that simple.
just need to stop making it so intimidating.
Yeah, it's really not. It's actually not that hard.
I think I psych myself out because I think it's so hard.
These the only ones that y'all
That's because they're right next to it.
17 to 23.
Right.
You get that whole lot.
You don't got 23 on here.
Man, I've never
Okay,
had a problem with anything like this.
21. I want to do another horizontal though, really.
Yeah, there is one.
That last one was horizontal. You just gotta flip it over. They can all be horizontal. Gosh, this thing sounds like I'm in a scary movie over here all the time.
Okay, let's do 19.
Yeah, anything's gonna help me, dude. So y'all,
Yeah, I'm the same
Yeah,
way.
me
If you do any of them, I'm trying to learn it, I guess.
19 section 6-2. Y equals x to the 4th minus 8x squared plus 16. Y equals 16 minus x to the 4th. Oh, those are two functions. Okay, let's graph both of them. X to the 4th minus 8x squared plus 16, and 16 minus x to the 4th graph. do. Well,
Goofy looking function, isn't it?
uh-huh.
Okay.
You can actually tell it's shaded in.
Yeah, I see what goes on there.
So, I mean, I remember doing it in high school, but I don't remember. Maybe.
So,
See, this
try to
one?
draw this.
This one is
Which one do you choose for the shade in? Or is it nowhere for that one?
This one goes on top.
You could probably teach us a lot easier ways to do stuff.
Yeah, does it just loop over and then come right back down?
Oh, underneath,
Kind of
right?
like a horseshoe. I think it just loops up like you had it.
Yeah.
It just kind of goes
Oh.
up and goes over and comes back down.
It goes on top, though? It goes on
I
top
can't
of all
tell.
this?
I can't tell. Yeah, there might be a little space right above that,
Mm-hmm.
but it doesn't matter because it stays above the other function the whole time when
They intersect right here.
Yeah, they might. I'm not sure.
So, yeah, they got to because those are going to be our boundaries, upper and lower bounds.
Oh, okay, yeah, because that's the only two. That's for that problem. That's the only thing that we were given. So yeah, they have to intersect. Yeah.
So,
So it comes up.
we want the area
touches
of all
the very
the-
top.
What's that?
It touches the very top.
Yeah, because that way it makes a boundary.
Yep.
I guess that's right. Or would it be where they intersect? The other two is a boundary.
That should be the lower bound, right? Right here?
Yeah,
Upper-
yeah. I guess
upper
you
bound,
need
lower
an upper
bound.
boundary. I guess.
I think.
Yeah.
So we got to find out what those are, too.
Yeah, it looks like the one's x equals 0, I think. But I don't know. I have to figure it out.
We can find the intersection, set it equal to each other. X to the fourth minus 8x squared plus 16 equals 16 minus x to the fourth. So,
Can you go in the calculator and do it?
yeah, it should be easier than that.
I don't know.
Second trace intersection.
Oh, yeah.
You gotta get it on the first curve, and then the second curve.
What is it?
Don't you put it on the other side of it?
Mm-hmm.
2, 0. There should be some more.
It's 8x squared. Let's say 20.
X cubed minus 8x squared plus 16. 16 minus x cubed.
Okay.
Or x to the fourth. X to the fourth on both numbers line.
Okay.
Well, I keep giving me 2, 0. They must.
I think that's 0. That's where the x is 2 and y is 0. So the lower limit is 0. That's giving you the intersection. So they might not touch up there at the top.
On the top. What about on the other side?
Because you might have to find the max on the second equation. And that's the top limit. I don't think they do
There
touch.
goes negative 2, 0. You don't think they do at the top?
I don't think they would give it to you if they did.
No, they do touch. If you look at the graph of it, they both go up to 16 and then come back down.
Okay.
So,
That was what?
so,
I mean, if you look at the table.
yeah. So the upper limit is 16 then?
Yeah, they both hit 16 on the table, yeah. 0x. You can just look at x equals 0
Oh, yeah,
like
the
that.
zeros right there.
Yes.
So what do we determine by that? I mean,
What did you have your window set at on your calculator?
oh, okay, I got you.
The scale, or the window, Y scale 3, Y max 25. That's the only thing I changed from standard.
Max 25. Okay.
Find the X.
We drew our horizontal lines. They give us the equation as y equals. That's for vertical. We want to go horizontal, so we got to solve these for x. No, we might be able to, yeah, we could do vertical.
Mm-hmm. Should be able to.
Yeah.
They're controlled.
So would you say 16 determined? I'm sorry.
I think that's the upper limit.
The upper limit?
I think.
Yeah. I think though. Are you gonna have to do it twice? Because there's two.
It
Or
looks like
should
it's
it be the
symmetric.
same? You just double it.
Yeah, it looks like symmetric.
Yeah.
So if you just do, if you just do the upper minus the lower of one of those.
Yeah. Which one's?
2 negative 2,
16 minus x of 4 is the upper.
2. Yeah. Yeah, so we're doing the vertical test. We got our bounds right here. These are our boundaries.
Okay. So it's 16 minus x to the 4.
See that? And then, so area equals 2, negative 2.
Oh, those are the boundaries. But if you're only doing one side, is it 0? Would it be negative 2 and 0?
No, wouldn't it be 6? If you're doing just one side of it, it'd be 16 over.
0.
It'd still be the upper function minus the lower function. The lower.
Yeah, it'd still be that, but we're talking about your boundaries. What would they be
Oh.
if you're just on one side? Wouldn't it be 16 over 0 or something like that? Or
And then times it by 2?
yeah, it'd be 16 over.
No, we're doing
Oh, no,
vertical, so
you're
it'd be
doing-
like negative 2, 0.
Oh yeah,
Or
it'd
0,
be
or
yeah,
0, 2.
Yeah, you're doing vertical. You could do horizontal on this one, couldn't you? Or no, then you'd have to find your x equals.
And
something.
yeah, then you had to solve that for x, and that's
Yeah.
a monster. So, you see that, Travis?
Yeah, so you choose which one you want to do? I mean,
No.
I don't
I
understand
would
that.
I would look at my boundaries. You know when they gave you that y equals 1
Yeah.
or x like that. If your boundaries are going like that, more than likely you're gonna do horizontal.
Okay.
If your boundaries are like this, more than likely you're gonna do vertical.
Okay.
I don't think it's gives one like this for the test.
Like like this hard. Nah,
Yeah.
nah.
It'd be like this.
Well, you're.
But you could still do negative 2 and 0 and times it by 2 also, right?
What's that?
Or does that not work? You can make your limits negative 2 to 0.
And then times
That's
it
a
by
lot
2.
easier to solve and then multiply it by 2.
We could try that.
Possibly. It'd be easy this way too. 2 and negative 2. It's not too bad. Just
So you want to do the 2 and negative 2?
Either way.
Yeah, that's fine. 2 and negative 2.
Okay.
I hope that works.
Yeah.
I think it should.
This is 19. So we got this from y. This could be y1, y2. y1 minus y2.
Yeah, they did 2 and 0 in the manual.
Did it?
I
Yeah.
think that's a lot because you completely get rid of half the math and then you get a number and you just multiply it by 2.
Okay.
How do you get rid of half of it?
Functions.
Because you have 0 as a number,
Do it
that's
twice.
going to
Yeah.
eliminate.
Oh yeah. No, I didn't even think about that. You're right. That's gonna. If you have 0,
It's gonna eliminate that at the end.
it'll give you plus 16.
That's the
That's
same
it. But it'll
times
get
it.
rid of
Yeah.
your 4 squared and your 8
That's
Yeah,
squared.
'cause that's what he was saying earlier, is just do that and times it by 2.
And you'll have 16 minus. What will it be? 16 minus 16. Yeah, no. So it will be 0 actually. So yeah, you get what we're saying. When you plug in 0 to that
At
function,
the antiderivative?
yeah.
Okay. Yeah, I see what you're
It
saying.
should give you Well, no, it'll give you 0. It's antiderivative, that's right. So it'll give you 0 all the way across because 16 will be 16x.
Okay.
Yeah.
So we're doing this half. So this is gonna be 2 times
You're
two,
right, Tim.
two
Yeah.
area. 2 times the area.
Good call.
First thing I understood today.
Step ahead of me.
So we got multiplied by 2, right? That
Yeah.
after we
Yeah.
get that answer, 2 to 0.
Yeah, exactly.
Let's go ahead and simplify this. 16 minus x to the 4th minus x to the 4th plus 8x squared minus 16. This cancels. This is negative 2x to the 4th plus 8x squared. 2, 0. Area equals.
Is it minus 16 or plus 16?
Where? Right here?
Yeah, I guess plus.
It's minus 16. I distributed that negative.
Okay. I'm with
So I'm gonna erase the graph and stuff, y'all.
We have an exam tomorrow.
That's fine. I'm gonna erase the graph. I'm gonna erase all this.
Yeah.
Yeah, it's cool.
We feel usually. So I got physics. Like it's supposed to be physics now. They say I leave, but you know they give you zeros.
So, we want to take the antiderivative of
She's
this.
gonna be-
This is 1. Is this?
Where'd the 2x and the 4th come from? I was
What's that?
the 2x to the 4th.
This one?
Yeah.
We had what do we have? We had
You had negative x to the 4th minus x to the 4th, so we just
Yeah.
added those together.
combine those.
Hold on. I don't know where.
So then we're gonna take the antiderivative of this. Take the negative 2 out first. X to the 5th over 5. That is the that's the u plus n plus 1 over n plus 1. We can use that for that one. They give you n for this one. For this one, they give you n minus 1. You can see it right here, really. For the remember you was asking me that? This is the antiderivative form, and they give you n minus 1 on top. For the derivative form, they give you got n on top. So when you take this and use this form, it's the derivative. It's like this form. They give you n. When you use this form, they give you n minus 1. I was trying to help him. You see that though?
You just okay. I got you. I mean,
Yeah, when you go backwards, it's just n plus 1. When you go the other way, it'd be n minus 1. Yeah.
And then you have to multiply that by 2.
so you're doing the antiderivative of the function at the bottom right now?
Yeah, right here.
Okay.
And I just use this. If you want to review a little bit, I can do it both. I can do the antiderivative both ways.
I'll go back and look at that. I think yeah. Later, and then get the big stuff now, I guess.
Well, antiderivative is the main thing.
Yeah, no, I gotta get the brush back over that.
So what did the book answer come up to me? What did they answer?
256 over 15.
256 over 15?
Mm-hmm.
I may have done something wrong, but I got 1 over 24 over 15.
Okay, so after this, it's f of
Unless that's divided
2
by
minus f of 0 equals 2a. Did you multiply by 2?
2. Yeah.
0, cancel it.
On which one?
Yeah. 'Cause those
For
are-
minus?
Yeah, that
Yeah,
would
that
cancel
you don't
it.
even have to do anything for that.
No, no. So I get 25.6.
25.6?
So,
What did it come out to be? X to the fifth over 5 plus what? For the antiderivative?
X to the fifth over 5 plus 8, x to the third over 3.
3. That's it, yeah.
We should just have to plug the 2 in there. Times it by 2.
times, what was that?
That was the book answer, Nick.
What was
What?
that?
What you just got?
Right here? That's the book answer?
17066 is what
Oh, 17066?
was what the book answer was, yeah.
Okay.
I mean, they put it as 256 over 15.
That's what everybody got? We got time for one more problem. Y'all want to,
Try one from 10 too.
number 10?
Hold on one second.
Okay.
Or 10 too.
Oh, 10 too? Try one from 10.
All right.
Yeah. I got it this time. I must type something
So
wrong.
just plug in the 2 in there.
Yeah, let me plug it in.
No, what are we doing? 1 from 10 to?
Oh, but you gotta do.
Do you want to do 1 from 10 6? Or, I mean, 10 6 6 6? Because that quiz is on that. Take home quiz.
Oh, dang it.
Which one, 10 2 or the other one?
I say 10 too because that's what the test is going to be on.
Okay. 10 2, number 1.
Work on the take home.
Yeah.
Section 10 2, number 1. X, integrate. X plus 1 dx. Get rid of the radical.
Which one did you say this was? I'm sorry.
Number 1, section
Okay,
10 2.
gotcha.
Let's see the notes over here somewhere. Okay. Can
Let me read you off the question.
no, I got it.
Oh, I'm sorry.
Oh, I was looking for. Okay, we're gonna like we did with the K, N, and list all that. We're gonna do that again, like this. We're gonna let U equal x plus 1 over 2. The formula is. Do you have the formula?
Yeah, it's, let's see. No, that's exact. You put, one of the formulas is U equals AX plus B, 1 over Q.
Okay, that's what U equals.
And
then they
then,
give you P over Q, right?
yeah, and then there's AX plus B, P over Q, I guess is what you're given. And then, the other one that you probably want is, let's see. It's X, I know what it is. You basically use the formula you have now, which is X
Yeah.
times the square root of that, and then
So-
you put in all your other. You just move the things around.
Yeah,
to
u
find
squared
what you
is-
need, yeah.
So we're gonna
So that's
square
the-
u.
Yeah, that's the
Okay.
only equation you gave us, I think.
Okay. So we square u, and we also solve for x, and then we take the derivative of x.
Yeah.
So first you let u equal, if they give you ax plus b p over q, you only use ax plus b 1 over q. So that means if, say they gave you 3 halves, but u's still only going to equal 1 half.
What do you mean gave you?
Like, okay, say the questions, for instance, the question might say that x plus 1 are 3 halves. You're gonna let u equal x to the 1 half still.
All the time?
It's if they give you p over q, you're gonna use 1 over q.
So it's whatever the denominator is.
Mhm.
Yeah.
That's what just happens to work this time.
Yeah.
But it wouldn't most of the time, because most of the time it's just going to be a square root, right?
Yeah, more than likely. Yeah. I don't think he's gonna try to mess you up like that.
Yeah.
But more than likely, it's gonna be very similar to the one from the homework. More than likely.
Probably the same one.
Hopefully.
So we're gonna square u. U squared equals x plus 1 to the 1 half times 2. That means that'll cancel out. So you're left with u squared equals x plus 1. If you solve for x right here.
Both sides. All right.
Yeah, square both sides. Because you want u squared.
Mm-hmm.
And then after you get that, you want x. So you want to solve for x. You see how this canceled out right here?
Mm-hmm.
Now you just want x. So x equals u squared minus 1. And you also want dx, the derivative of x, which is 2u.
Okay.
Come back up. So now we just start plugging in. dx, I don't completely understand this, but you put du at the end of that.
Yeah, what happens is basically you got to have what dx equals in that equation, and in the original equation, and what dx equals in that equation would be du, or 2u over du, because it's that derivative.
Oh, you're going to
And
plug in
dx
that,
is a derivative.
plug in the x to the original equation, right?
Yeah,
And then you plug in the derivative
because
to the dx.
yeah, because if you had the derivative of x, it would be dx. So dx equals.
But since there's no dx, oh yeah, there is. Okay.
Yeah. So now just plugging in.
Yeah.
X, you got x equals u squared plus minus 1. X plus 1 to the 1 half equals u. Dx equals 2u du. And
Well, where did the plus 1 go? X plus 1. Don't you have to keep that in there?
No, x equals u squared minus 1.
You solved for x.
oh yeah, this you talking about right here? Yeah, this is let's get u squared minus 1. This is x.
Yeah, I get that.
Okay, that's x. That's u is
u is
x
x
plus
plus
1.
1 to the 1 half, which was your. Yeah.
and this is dx.
Is yeah du.
So basically that's your original. That's your original.
Yeah.
x plus 1 half dx.
I'll get confused, real confused there.
Hey, look at this. It was the same problem, basically, right? It's what he's showing up there. You found your u, you found your x and your dx, right? Which
Under U.
is what you need to change over your equation. You see here how these change over. See how you follow these arrows. Here's your original equation, right? X we know equals u squared minus 1.
Yep.
And we know that u equals x plus 1 up here. And that we know that 2 du equals dx, which is the original. So do you see how they make a new equation out of the equation that we had?
That just went away.
Which went away?
The
X?
square root.
Hey,
No, the square root didn't go away. Square root is up here. See, the square root of x plus 1 equals u, right? U equals x plus 1 to the 1/2, which is your square root. But this equation here, u equals, is the equation that he gave us, 1 over q, right?
Oh, fellas,
Okay.
we'll continue in the morning, 9:15. That'll wrap up the SI session for today.